to prepare this, we actually take cabbage, boil it up, blend it up, and then strain out the liquid, and this is what we're left with here. So our cabbage juice is sensitive to different pHs, and that's because of special pigments inside of here called anthocyanins. So they're really special, and they change colors depending on what we put them in. So pH is simply a measure of the hydrogen ions inside of a mixture. So if we look at water, there's an equal amount of hydrogen ions as well as hydroxyl ions. And what that does is blends together to make H2O. So if we look at water and we pour this in, it's just going to be this purple color. Now over here on this end of the scale, we've got acids, and on this end of the scale, we've got bases. So as we pour our juice in there, our cabbage juice, we're going to see it goes in purple, but it's going to be a different color. Do you have any guesses what color this might turn if I pour it into this container? So it's clear and purple that are going to mix. What color do you think it's going to make? Might just be clear? All right, let's find out. So as we pour it in there, it starts to turn pink. Does this look the same? No, not quite, right? And that's because of this special chemical that we added in there. It's called citric acid. And if you've ever had any sour candies or sour foods, that's because of this stuff right here. So the citric acid helps to give it that sour flavor, but it's also an acid. Sometimes if you eat too many sour candies, you'll notice that your tongue kind of starts to hurt. So we'll move over to this end of the scale now. So on this extreme, so this one looks kind of a cloudy color. Do you think it's going to turn the same color as that one over there? Green? So it's going to go from purple to green, you think?
Oh my goodness.
You were absolutely right on that one. That was a good guess. So it turns green in the presence of a base. So again, what that tells us is that this one has a lot more of those hydrogen atoms or hydrogen ions. Can you say hydrogen? Hydrogen, very good. And this one has less of the hydrogen ions. All right, so we'll come back over to this side. And this one is vinegar. Maybe you've had this in food before. Some people use it to make salad dressings and different things like that. And it also has sort of a sour taste to it. So what do you think this one's going to be? What color? Red? All right, so this one's a little bit closer to this color, purple here, and that's because it's closer to water than this one is. So this one has lots and lots of extra hydrogen ions. This one does not have as many of those hydrogen ions floating around. All right, so we're going to go back to this side, and you can see lots and lots of hydrogen, a little bit less hydrogen. If we had water, which is what's in here, there is going to be equal amounts. This one does not have enough ones available, and this one really does not have hydrogen available. So what color do you think on this one?
Yellow.
Yellow, let's see.
Blue.
This one's more of a greenish blue. So you can see we get a really cool rainbow of colors. So we had citric acid here. This one here was the vinegar. This is our solution, which is dissolved in water. So if we place that in water, it would look the same. This one is baking soda here. And then this one is washing soda. So this is a special chemical to be able to clean our clothes really well. So maybe when you get home and you wash your Superman outfit, if you want it to be really clean, you can use this stuff here. Now what is interesting is if we take these chemicals and we pour them into the same container, what do you think is going to happen then? Do you think it's going to be the same color that we have here when they're separate? So let's see, let's pour that one in first. then slowly, we're going to add in a little bit of this here. Whoops. Got to actually make it into the container. So you can see it starts to turn more purple, like the original one that we started with. And what do you think will happen if I add too much of this? Let's see. So eventually, it starts to turn that nice dark purple color. And remember, that's what we started with here. So they're almost the same color, and that's because now this has balanced out the hydrogen ions. And remember, that's what gave us these awesome colors. So we can try it with this one here, and then a little bit of the green one, or bluish green. So just adding a little bit. And what else do you see forming on there? Do you see any bubbles there? So it releases bubbles. And if we take our baking soda and vinegar, that would actually create lots and lots of bubbles. But you can see we can make it back to the original one. And then we'll do it one more time here. And this is our vinegar mixed with our really strong base. And finally, we'll mix these two together. So the strong acid and our strong base here. And we start to change their color just like that. So now they're almost all the same color because we just balance things out there. So again, this is absolutely that you can try at home. Thank you for joining us. This is absolutely something that you can try at home. So pH cabbage, actually, if you check out our website, there's a video up there by a really cool guy, and he shows you how to make the pH cabbage juice, and then all the different experiments that you see here, how to make them, how to make the solutions, and then also how to make pH test strips. So those were really, really convenient, and out of this you can probably get hundreds of test strips. Instead of just having to pour it in, you can take those test strips and just dip them in, and that'll show you the pH of your solution. You can even use it to test your water at home, test the pH of your water at home. You'll notice that it is a little bit on the more basic scale, so it's going to be closer to these colors, a little bit of a bluish color, if you're in Florida, because we do have hard water here, which means that it has less hydrogen ions available, just like the base is over on this side. So now I've confused myself. I don't remember which container was the original one, but we can see again they are nice and balanced out, and that's just by mixing those together. So are going to be our bases. All right, do we have any questions from our viewers on Facebook? All right, do we have any questions from our audience? Why did it turn pink? So that was because of those special molecules that are inside of here, those special pigments. If you remember, I called them anthocyanins.